Hello, and welcome to this eSchool News webcast. My name is Andrew Barber, and I'm a senior contributing editor here at eSchool News. I'll be acting as the moderator for today's presentation, which is sponsored by Stratasys. It's titled An Introduction to 3D Printing Modules in the Classroom. And today we're going to take a look at how teachers can use curriculum modules to take their students through a full product development cycle. In this case, a computer mouse project. Before I introduce our guest speakers, I want to take a few moments, though, just to highlight a couple of items. First, today's event will be recorded, so you don't have to worry about taking notes. In a couple of days, you'll receive an email from us that contains a link to the recorded event, and you'll also be able to download a PDF of the presentation from that same email. And second, please ask questions. You don't feel as if you have to wait till the end. Anytime during the presentation, if you have a question, just type it into the Q&A box on your console and hit the submit button. I hope to have 5 or 10 minutes at the end when our speakers can answer some of your questions. We also have a chat function which can be launched by the brown group chat icon down at the bottom of your screen on that toolbar. Use chat to talk among yourselves or to contact me or the eSchool News team with any technical issues or, for that matter, anything at all. However, please don't use the chat function to ask our speakers questions. They simply won't have time to monitor the chats while they are giving their talk. If you want to ask a question, again, please use the Q&A panel instead. With that out of the way, let me introduce our speakers. Jesse Reutenberg has been the head of education for Stratasys for the past 4 years. He has a BA from the University of Minnesota and is a former science teacher. He's been involved in 3D printing, additive manufacturing, and direct digital manufacturing for the past 7 years. Our second speaker, Mike Santolupo, has been teaching technological design at John Paul II Catholic Secondary School in Ontario since 1991. Mike's been a leader in the development of innovative design initiatives, and under his direction, the Technological Design Department at John Paul is recognized as one of the finest in North America. Mike has many years of mechanical engineering experience, including stints with companies in Winnipeg, Toronto, and London. And with more than 30 years of CAD experience, Mike continues to lead in the implementation of computer-aided design and 3D printing in the secondary school curriculum. Welcome, Jesse and Mike. It's an honor to have you here today. Jesse, why don't you get us started?
Thank you, everybody, for joining us. This is Jesse Reutenberg of Stratasys. We've got some really exciting things to talk about. One of our longtime customers, Mike Santolupo, is going to really dig into what he's created to engage his students in the design, engineering, 3D printing aspects. I'm going to start by giving you a brief overview of who Stratasys is as a company. My agenda is going to focus on who we are, what others are doing in education, and the next steps. Stratasys is making large investments to ensure that all of our customers out there have necessary tools to continue to lead in the educational space. So Stratasys is the worldwide leader in additive manufacturing. We're a company that's based in Minnesota. We have manufacturing plants in Eden Prairie, Minnesota. We also have manufacturing plants in Rehovot, Israel. But then we have facilities that are manufacturing, operating in Brooklyn, New York, in Billerica, Massachusetts, Nassau, Vermont, Rancho Cucamonga, California, and then offices across the globe. We feel like our tools and our solutions are empowering designers and creators to fail faster. Failing fast is a term that those in industry love to hear. Finding solutions as quick as possible speed up time to market. And what we see in education, failing fast, is phenomenal because it actually engages students in making engineering decisions, applying knowledge that they learned in a lecture and in reading. The ability to work with what you're thinking of on a computer screen, producing it, printing it out, and then evaluating, making design iterations. It's truly an impactful product when used to its capabilities. At Stratasys, we're also building a digital ecosystem. You'll see later a couple of the steps that we took to help build content out there for educators. And we are a solutions company. We focus on software. We focus on the hardware. But then we're also focusing on adding more to what our customers need and what they've asked us for. And so we'll get into that as well. It's our educational imperative to shape the future and give the opportunities for instructors out there to build on what's going on and inspire those students to get more involved in the STEM, the STEAM areas. We are leading as an organization. Like I said before, we're investing a lot of dollars. We put together special packaging and pricing for education because we feel that it is a key imperative of our country and from our company to get more people involved in manufacturing, engineering, and creating. Getting their hands dirty and engaging in applied learning is key. And then we're here to grow. We're growing our global ecosystem, building out more products that lead to a solution rather than just a product that produces. So the vision is inspiring, engaging students of all ages and in all fields across disciplines. In elementary education, we're seeing people start to use 3D printing. Today I was meeting with librarians from elementary schools because their elementary schools are creating that library more into adding and turning it into a technology space. And so giving kindergartners through fifth graders access to this type of technology and getting them immersed in exploration in those STEM fields. We see some of our customers doing rocket launches, nose cones and fins with fourth graders. Simple design, but yet CAD design. Those students launching those rockets and seeing the decisions that they made change based on their nose cones or their fins. And this is just one example of where elementary is using it. And seeing young ladies get inspired to get involved in those engineering areas. Middle and high school. We're seeing middle schools, high schools go down the path of digital labs, maker spaces, technology labs. The shop class of yesterday has evolved. We start to see more and more of what we call digital fabrication, using the skills students have learned in traditional shop courses, woodworking, mill, lathe, and adding that to the new world of technology with laser engravers, 3D printers, building out robots with laser engraved piece, electronics, programming, and 3D printing. The students that are going through these type of tasks are so well-rounded because they're working in teams. They're building up competencies that make them so much more powerful as a student and, once again, applied learning. They're engaging in what they're reading and what they're being lectured on and making it stick. And as you see this progression as we get to the college and the universities, the labs that these students get access to is a recruiting tool. Students that go to school and at a middle school or high school that have a 3D printer, they're engaging with the college and going on a recruiting visit. These young engineers, these young designers are being recruited like athletes these days, because these are the students that are going to allow a university to create more industry partnerships. That picture right there of that jet engine was seen by a company, and that company then engaged with this university to do further research in the aerospace world. The medical world. More and more medical groups in research and training are getting involved with 3D printing, because the capability to touch a piece before someone engages in a surgery or an operation is the ultimate time saver. And that's probably the most expensive place on earth, is that the operating room. Every minute counts, and not only in money, but as in a life-saving opportunity. And then we're seeing a lot of people use the medical pieces as training capability to get a young doctor engaged in a model of what they see on that specific patient is key. And then what we're seeing is outreach, changing people's lives. And we've seen it in multiple areas where 3D printing is key to everything due to the fact that customization is happening. But what we see there is, once again, digital fabrication, using electronics, metal, plastic, using all tools available. These are the students that are really going to change the world and change the companies out there. We're also seeing it in the college and university level that access isn't just to or just for aerospace engineers in your capstone class or mechanical engineer as a junior and senior. People are giving more access to students across the campus, the art students, the business students, the anthropology students. That's a huge change in where 3D printing has been and where it is going to go. It's exciting because those students getting access, that means more of them are understanding the digital world, and they're, once again, back to it, applying the knowledge that they're gaining. And we're seeing universities start up classes that they want a certain amount from the engineering fields, the design fields, and the business fields, and basically creating little companies and think tanks. It's truly exciting. It makes me want to go back to school and go through this type of learning. We're also seeing colleges go down a certificate path. Additive manufacturing is becoming a key imperative to local industry, and they're pushing the colleges to make sure that this is part of their machining, engineering, and robotics programs. Another cool piece that we're seeing is the products being used in end-of-arm tooling, a jigs and fixtures, unique attributes that people that have the equipment are leading down a path because they can find a solution. This class is all about programming a robot. What they've added to this class is having to design some sort of 3D printed end effector, which solves the problem. So they go from just programming to now having a problem, solving a problem, and programming. And then jigs and fixtures. It's one of the faster growing markets in 3D printing. This school is now teaching it. Why would you use a 3D printed fixture versus a machine fixture? So I'd like to now introduce Mike Santolupo. Like I said, one of our longtime customers of Stratasys. We engaged with him probably a year ago to talk more about what he's doing in his classroom because he takes a high school classroom to another level with 3D printing involved. And he really focuses on digital manufacturing because he doesn't 3D print everything in the classroom, but he has some key projects that 3D printing is a key aspect of it, or a key contributor, or even having his students saying, hey, I'm doing this and I'm doing it with all this stuff. Could I use the 3D printer to do this piece? So it goes through an evaluation process. It is my true pleasure and honor to introduce Mike Santolupo to talk for the rest of this webinar.
Thank you very much, Jesse. Those are kind words. It is my pleasure to be here with you today. My goal from my presentation is twofold, is to pass on what I think are great reasons why these projects, these modules, project modules that Stratasys has designed specifically for high school, what are the benefits and how I think they can help work in any school across any education district. Secondly is the advantages that I have found over my years using 3D printing, and specifically the last 2 years using the uPrint machine. So that's the focus of what I'd like to do today. I'd just like to start by giving you a little bit about my background. I've been teaching in at John Paul Catholic Secondary School in London, Ontario, Canada for this is my 25th year. It has been an amazing experience working with young artists and designers and architects and engineers over the last 2 decades. Adding 3D printing to the classroom has made things just an amazing experience and opportunity for the students that I work with day in and day out. The school itself, we have about 1,000 students, publicly funded school. The design program that I have developed over the years are standalone, free. These are full credit, standalone grade 9, 10, 11, and 12 with the focus of design. We have some specialized courses that focus on animation, focus on engineering and industrial design and architecture. And background that John Paul has had with 3D printing, we've been fortunate. We've had a Dimension SST machine for the past 8 years, and we've added, starting last year, the uPrint machine. So we have 2 machines going full-time, literally 24/7. It's been a fantastic experience for me to have 3D printing added to my program, and it's made things so much better. So I'm hoping that this presentation will allow you to understand how 3D printing is, how it can help you, and how these modules can also be beneficial to your environment. So this is what I'd like to try to do this day, is to begin by discussing a little bit about the design brief. So the actual module that Stratasys has created, a little bit in terms of the content that's inside, that's built within what I call the design brief, and then the remaining points are specific aspects of the project that I've gone through. I'm going to be focusing on a grade 9 project that I've done. I just recently completed that at the beginning of this semester, back in September, with a fresh group of students, and then going through the different stages, beginning with research, doing what I call concept sketches, scaled sketches, introducing to CAD, creating 2D CAD drawings, producing a 3D CAD drawing, which is then exported, and we use these STL files to bring to the uPrint machine to do our 3D printing. I had a little thing at the end of the project where we had the students evaluate each other's designs, and I'll explain that experience. That was a great experience. And then I'd like to finish off with the benefits of using the curriculum and the benefits of using a uPrint machine. So that's what I would like to do with you today. So and before I begin with the research, just a little bit in terms of the content that's within the actual module. The module is a very comprehensive multi-page document that explains and lists many things that will help the students and help the teachers, the classroom teachers, in terms of the way that the project can be delivered. Of course, the module is just a guide. There are things that you may want to add or modify that suit your environment, and absolutely it's just something that's going to be used as a resource that may be beneficial in your environment. The module includes a list of the design criteria, so there's specific things, and everything that I will relate to will be to the computer mouse project. So, for example, the module listed for this computer mouse project for my grade 9 students is that it was that there was a minimum of 2 buttons, that there would be decisions to shape the button with ergonomics in mind. We are going to make the computer mouse wireless, and if the students want to include a scrolling mouse wheel, that would be optional. So trying to give some direction for the students, but also giving it as much opportunity for some additional features if the students felt that was necessary. The module also includes project requirements. It lists outcomes from the project. It has a section that goes through the workflow so the teacher and students can see exactly the step-by-step process of the project that they're about to do. I think it's important when I present new information, especially introducing a project, that the students have a sense of how the project will flow from one stage to the other. I have the module includes some exemplars, some student exemplars, so the students and the teacher have a sense what is capable for people at that age. And then the end of it, there are 2 rubrics, which are very useful in terms of helping us assess what it is that the students have just created for you. So I find the module was a terrific package to use to go through the project. I began the project, and included in the module is the research. The module included 2 links to particular articles on the internet. The internet is a fantastic resource of possibilities in terms of having the students research specific areas and finding examples of computer mice that they find interesting. The part that I focus on with the students is not that they're looking at a mouse to copy it. They're looking at a mouse. There may be an aspect of the mouse, the material, the color, particular shape, or something specific to that mouse that they may want to incorporate in theirs. And there may be just something that they can have an idea based on looking at someone else's idea. And that's a normal professional workflow. Anytime Ford is going to do a new pickup, they will look at what is existing in the fleet, whether it's Chrysler's or General Motors or someone overseas. That's just a normal professional workflow to see what the competition is doing. So I encourage the students to do research. There are 2 links included in the module. One that talks about that I found extremely helpful is there was a history of the Apple, the first Apple mouse. So it's nice for me to have the students have a sense of how the history of the product, how the product evolved. These students obviously are far too young to appreciate what computer mice were like back in the late 70s and early 80s. So it's nice for them to get a sense. I think they appreciate and get a kick out of it when they see for them, very old technology. So the research is useful. I also encourage the students to do some of their own research, and anything that they can do to help look so for themselves is to have a sense of some possibilities. The more research they do, the better it is, and that's the way I try to press upon them. After the research is completed, then we'll spend some time as a group going through the design brief. So this is specifically, I give this to them. It's a great tool for me, and it's a great tool for them. And when I'm speaking about something specific, I'll say, okay, go to page 4. We're going to discuss this aspect of the computer mouse project, and it gives examples. It lays it out. So it is a super document that allows the teacher and the students to see exactly how the project's going to flow. So I would definitely recommend allowing the students to get their hands on it. So project begins with encouraging the students to do a series of what I call concept sketches. So these are freehand, typically pencil sketches. I provide them with 11 by 17 sheets. I have pieces of Borco. I've cut up old Borco sheets For those people who know traditional drafting, that's the old surface for drafting boards. So trying to give them a professional environment. I supply them with the pencils and rulers and erasing shields and templates and everything that they need to create a series of both concept and scale sketches. So this concept is a freehand. So they're taking everything that they have learned and committed to memory and looked at during the research stage. So now they're thinking about it, and now they're going to transfer that onto a paper. The more sketches they do, the better. There's an excellent section inside the toolkit, which is going to be available through Stratasys, which has a list of specific things that should be considered when doing concept sketch. And then I focus specifically on, for the students, doing particular orthographic views. So possible side views, top views, front views. So as many different possible profiles without worrying about too much detail allows them to get through, and hopefully by the end of a couple of days they have a page of about 10 to 12 different concept sketches that they would consider as part of the design. I have included a series of 4 different portions of concept sketches from students in the class that did this back in September. On the far left, Josh, what I liked about that one is you could see how he went with a series of side view profiles and just kind of modified it until he ended up with something that he liked. I love how he marked the top one. He has this one. So he's now done a series of the concept sketches and decided that's the one I want to focus on. The one in the middle, Victoria, she's done a great job of doing both, having a matching front view, side view. You didn't necessarily have to do that, but in her case, she found that useful. In the top corner there, another one where it's just a great little bit of shading, side view, top view. The kids don't have to be exceptional sketchers. These sketches, really, what I tell them is the sketches are intended for them. They're the ones that are going to be interpreting their work. What I like too about the bottom corner one, Brandon did an amazing job. So he was already thinking about dimensions, which was fantastic. So he was already going through different slices at 3 parts of his top view and deciding what would be reasonable dimensions. So he's really already thinking ahead. So from the concept sketches, I'm asked the students to narrow that down to a one. So one design, or maybe a combination of 2 designs to select one, and then the scaled sketch is a series of 3 views where it is and they're drawing them now. They're drawing them on a grid paper. They're drawing them actual size, and everything is done with an instrument. So they're far more precise. They're accurate. They're doing a side view, top view, and front view, and then all the details come out in the scaled sketch. So anything that they're thinking about needs to, in terms of the buttons, if they're doing a scroll wheel, if they're adding any features, anything else needs to be incorporated in these scaled sketches. And once again, I have some examples of 3 students' scale sketches. In my case, being in Canada, metric is fairly common. So what I provided the students with graph paper with 5mm squares. If you're going to work in an imperial environment, then you can easily find 1/4-inch graph paper. And then for them, it's very easy to find measurements. They're just timesing. They're just, for example, for the grid paper, they're just my grid in metric. They're just adding up the squares, timesing by 5, and those are their measurements. And they need to know 3 overall measurements: the overall length, the overall width, and the overall height. And those are actual size. So they've now been very specific and know exactly now what their mouse is going to look like. Then we go through a process, and in my case, I used AutoCAD. I've used several different design softwares over the years, but I find in terms of starting with a brand new group. So this, and just to back up a little bit, these grade 9s have had no design experience. They have no experience in design type projects. They have no experience in CAD software or 3D printing. So this was, and I found that the computer mouse project was a perfect project to start fresh eyes, no experience, everyone starting from the same point. So then going through a series of a few days, and for those who know AutoCAD, and then at this point, I'm splitting the period. We have 75-minute periods where I'm now allowing them to finish their scale sketches, and then for the last 20, 25 minutes doing a little bit of AutoCAD, a little bit to get them a sense of what they need to know. And then by the time their scaled sketches are done, they will know enough about AutoCAD to be able to recreate what it is they need to do. So what they basically do is recreating your scaled sketches in a CAD environment. So for those that know AutoCAD, there's a series of between offset and trim and doing line and some arcs to allow them to do the 3 different views. So I have a series of 11 different examples of students' 3-view drawings, front top. Some of them are front view or back view, but they all have 3 views. AutoCAD provides them the opportunity to do a little bit of color and grading, which brings the drawings to life, which is exceptional and a great process. So this is probably about 2.5, 3 weeks into the semester. We've gone through concept, scaled, and now our 2D AutoCAD is completed. And then we go through a stage where we're utilizing the geometry from the 2D drawings to create a 3D drawing. So they're using the information, the profile from the side view, the profile from the front view and the top view to create their 3D drawings. We do this as a group. There's probably about a period and a half to go from 2D to 3D. So I have a series of examples of finished 3D mice. So it's pretty exciting to go from this 2D. So here they are just literally weeks ago thinking of a mouse, and now they have a fully 3D digital mouse in front of them. Just incredible in terms of what their expectations, maybe it looks a little different, or it's exactly what I thought it would look like. So there's a series of different examples of students, a 3D AutoCAD drawings using a shader just to give it a little more realistic look. And then the exciting part of this project is taking the 3D file. So there are 2 types of CAD 3D drawings. It could be a surface. So if you're working in SketchUp or Alias or Rhino, those are surfaces or Mudbox. And if you're working with 3D like Inventor or AutoCAD or SolidWorks, those are called 3D solids. So we're taking our 3D solid file, exporting it as an STL file. So right in AutoCAD, there's a rapid prototype command that allows us to take our 3D file, basically preparing it for the 3D printer, and then these files are brought into the software called Catalyst, which is specific to Stratasys, and it's brought into an environment where they're then sent to in this case, the uPrint machine. So basically it's taking the 3D file, exporting it to an STL file, and then the STL file is brought into Catalyst, and then from Catalyst it's sent to the uPrint machine. So we went through in small groups, and the students and I was fortunate enough that I'd had a fairly good stockpile of material that I was able to print each student's project. The other thing that I like about the Computer Mouse project is it's a great project for 3D printing and printing it actual size. So we were able to print the actual size models at the end of the process. So every student was given was allowed to 3D print their project, and incredible the reaction. So when you see a student's face light up for the first time, they're holding this object in their hand that is theirs. They own it. They own every aspect of it. They put it on the ground, just like you're in your store. You put it on the ground, you put your hand over the top, and you have a sense of how it would work. Now, this is not a working prototype. It's obviously a scaled model. There's so much that the kids can understand about their design just based on putting their hand on it, get a sense of the how does it look? What's the ergonomics like? Would it be easy to use? And those are things, and that's the first thing they said. I remember there was one, Brandon, which was one of the students profiled in the sketching. As soon as he put his hand on top, he said it's too small. So he already realizes that it would be a great, if they were going back and redesigning it like they do in a professional environment, he would make it maybe 15% larger, maybe widen it a bit. So every student had certain things that I think they would redo if they had another opportunity, which is a normal professional workflow. In a professional environment, they go back and forth 7, 8, 10, 15 times until the 3D printed product is exactly the way that they want it to be. 6 examples of finished 3D printed computer mice. So what I love too is every student had their own idea what the mouse should look like. Some were a little small, some were large, some had more curves. They all had their own idea what an everyday product that we use and take for granted. They had a different take on it, and some came up with some clever and very interesting, unique ideas. just a fantastic product and project to 3D print. And one of the things that I ended up doing to finish it off, and I thought it was appropriate, is we spent one class evaluating each other. So the students had a score sheet, and they had to evaluate everyone in the class except their own. There was three criteria. They had to assess comfort, aesthetics, and size. We had a scale from 5 to 10, and everyone went through and graded each other's. And in the end, it was just a wonderful experience, a wonderful way to wrap up the project. I love how engaged they were in the idea of being able to assess each other's designs, and it wasn't really a competition. I think they really enjoyed it. And then one of the things I thought that was just kind of cool is I just drew up a quick mouse, and I just made little trophies first, second, and third, and based on the students' selections, I handed those out, and of course they brought those home, and hopefully they're somewhere in their bedroom or in their bookcase. So it was just a fantastic, I think, project from start to finish, going through a process to me that makes a lot of sense. The module did a wonderful job of laying out the steps and then being able to actually understand what they're doing and what's going to be next. And one of the things that I would like to finish off with my work is twofold. So the benefits for working and using, the benefits that I've had of having a 3D printer in my environment for the last 8 years and the uPrint machine for the last 2 years is the opportunity to create models that I can't do in a traditional sense. There are certain shapes, and the computer mouse is a perfect example. It would be extremely difficult for me to use foam or clay or mapboard or foam core, traditional model materials, to create a very precise and professionally looking model. So I like the fact that the students are being able to use a professional workflow. They're doing the same thing that has been done in design offices all over the world. And they appreciate that. The power of creating a design from scratch, 3D printing it, and having that in your hand is incredible, and especially for young folks, these young designers who understand technology more than any age group. This generation truly gets it in terms, like I said, they've never used CAD, they never have had exposure to 3D printing, they've never done a design process, and with the course of 4 or 5 weeks, we went through start to finish, and everyone finished it. So for me, the 3D printing is a no-brainer. Having the opportunity to have one in your classroom has so many benefits to the students and to the teacher. I don't 3D print everything, as Jesse had mentioned earlier. There are still a lot of traditional things that I do in terms of some industrial design models I still do with machining foam. A lot of the architectural models I still do with mapboard and foam core in a normal environment. But there are many things that I 3D print now that I never had an opportunity to do before, whether it's concept cars or motorcycles or chess sets or kind of creatures coming out of my box or ZBrush. There's just an unbelievable and unlimited possibilities. I'm doing a project now where we're working, my senior class is working with the local transit commission, and we're actually designing a bus shelter. We're 3D printing small-scale bus shelters, 3D printing people, and all the accessories that go with that, and it's just been fantastic. And just to be able to understand the space is so much better with a physical model than it is. There's certain things that drawings just can't do for you. So saying all that, I think for me, having a 3D printer and a uPrint, especially in these last 8 years, has been fantastic. Has allowed me to do certain things that just make things better for me and for my students. And then the last few things that I would like to leave with you is a list of some points specific to what I think the benefits are using the curriculum. My understanding is that Stratasys will be releasing a series of projects suited for different levels, different grades, and in the end, you will choose a project that will be suitable for your environment, the design software that you're using, the machine that you happen to have, and the students that you have in front of you. So it is the curriculum is a great way for the students to learn design, use CAD, do 3D printing in one project. So my grade 9 students, after 5 weeks of high school, just starting high school, they have an understanding of the design process. They've worked with AutoCAD 2D. They've created a 3D drawing. They've gone through the process of taking that 3D drawing and bringing it into Catalyst software, and then taking this Catalyst software and then 3D printing their project that they've designed. And each student has done that. Incredibly powerful. The module makes the step-by-step very, very, very easy. And for me, the success is having everyone completed. And I was fortunate that I had every student start and finish. And I think the module had a big part in allowing me to have that happen. The module gives a sense of the complete design process in front of them. So if the kids want to have an understanding of what the project will look like, so from day one, when I'm explaining it to them, throughout the entire 5 weeks, they're allowed to look through each page as many times as they need to have a sense of where they're going. A lot of kids, I think, like to know, so why am I doing this? So when the students would think, I had students ask me, well, why are we reproducing our scale sketches in AutoCAD when we already had them on paper? And then saying, well, if you refer to the module, we're going to use that 2D geometry, and that's going to help us create our 3D CAD drawings. So if they have an understanding of how and why we're doing things, it makes it easy. Students like to know why they're doing it, and also I think where we're going, what's going to be next, and I think that's very important. The module is packed with examples and exemplars from students. So it is nice, and one of the things that I did when I brought the module up is I went to the page and I went through each stage and I said, this is what you're capable of doing. This is the kind of work that I can, not only you're capable of doing, that I expect. So it allows me for them to see what the expectation is from me. So these are the specific project requirements that you're going to be doing during this process, and this is this is the level that I expect. And the module has that embedded in the several pages, which I found was extremely helpful. And for me, it's just a nice, well-organized, it's accessible, and for teachers and for students. So it's great for the students. There's a section where it's called workflow, and allows the students or the teacher to have a sense, okay, these are the 5 steps, and today we're going to be here, and my goal is that by Wednesday we can be on this step, and then so on and so on. So it has it allows the teacher to kind of schedule, the next 4 weeks. This is where I think I should be the beginning of week 3, generally. So I think there are several, excellent reasons why the curriculum worked for me and how I think it can work for you. And of course, in conjunction with 3D printing and specifically in my case, the uPrint machine, those two work beautifully together. So having a curriculum, having a uPrint machine, having a fresh set of students. Okay, let's start fresh. Let's do this together. So I think there's been so many reasons why I think this has been extremely positive project for me, and having both tools. So having the physical tool of the uPrint machine and having the digital bundle that Stratasys has provided with me allowed, I think, made success for me easier. So I'd like to thank everyone for listening, and I'd love to pass this back on to Andrew, and thank you everyone for hearing my story.
All right. Well, thank you so much, Jesse, and thank you, Mike. It's really fascinating to watch the students go through that whole design process and see what they came up with. It was actually really quite inspiring. Before we move on to the Q&A section, I'd just like to apologize for the dead space that we all experienced for about 5 minutes at the beginning of this seminar. It was small technical difficulties we were having. I suppose we could all think of it as 5 minutes of quiet reflection. But anyway, we have about 10 minutes left, and maybe we'll go a couple minutes long. If everyone wants to stick around to make up for those lost minutes, we'll take questions for maybe a couple minutes longer. But why don't we turn to those questions? So, Mike, let's talk a bit about some of the sort of the basics of the program. Someone was asking about the question of, they've got 15 students. How much time? How long does it take to print 15 mice? How long does it take? Is it like 2 hours for each mouse? And how did you budget that? And when did you do it?
That's a great question. There's absolutely what I do is, in terms of having it for years, in terms of a system. In this case, I have the student with me, and we're doing it together. Obviously, I'm doing most of the work. I'm allowing them to have an understanding of what's going by. Typically, and there are 2 settings, so that's a great. I'm glad you asked that. You can print any project solid. So depending on the need and the function of the part you're printing, you can do a solid piece. Now in this case, where they're a little bit larger and they don't have to have any rigorous activity, there is a low density setting which basically creates a structure inside and doesn't fill it. It uses less material and also allows the print to go quicker. Typical computer mouse would be between 4 and 5 hours that I found. Now, what I was able to do is the tray that you're dealing with, and I'll use the uPrint machine as an example, is 8 inches by 8 inches. So you can continue to add computer mice until the tray is full. I was able to add 5 mice on one, so once they were all on there, it was a 24-hour print job. I started it, and then over a day, so basically between 3 and 4 days, I had all the mice printed. And like I said, I literally print 24/7. My first job in the morning when I get into school at about 5 after 7 is I go to the machine, find out what's in there, pop it out, put a new tray in, do the next print. So you have to be fairly efficient. I do my best to keep the machine running. And in this case, especially with grade 9s, I thought it was fairly important that they get their mice as soon as possible. Once the first few were printed out, they were all fairly excited, and I want to make sure that they all had that excitement within a few days. So within 3 days, 4 days, it's fairly reasonable with 15. In fact, my class, I had 15 as well. So 3 days, 4 days, I think you can have them all 3D printed. But you have to put all of them on the tray, and you can print 4 or 5 at once. And once you start it, then the machine does the work, which is the best part. You don't have to be there, which is the best part of it all.
Andrew, to Mike's point, that's the difference between a professional piece of equipment and a hobbyist consumer desktop level piece of equipment, is that reliability factor, that understanding that I'm going to click print and this is going to go for 20 hours while I'm gone, 48 hours while it's printing over the weekend, and I'm going to come back in and it's going to have a completed part.
Yeah, that's absolutely, Jesse. I've had that many times when I just have the confidence that it really doesn't matter how long the print is. I'm just going to start it, and when I come in the morning, there they are. And just from my personal experience and people I've talked to, the 3D printing world, it's like most things. You get what you pay for. So if you're paying $1,000, you will get a machine that's worth $1,000. If you're paying something that's 10 or 15 or 20, there is an exponential difference in terms of what that machine will do for you. And that is a very, very, very clear in the 3D printing world, for sure.
Right, Mike, you also you talked about the 2 different levels, the low-density print and the high-density print. Can you talk a little bit about the cost to print a mouse? I'm assuming at the low density, what is the school looking at for mouse?
Low density, I'm not sure what your price are. I know the materials now are half the price they were last year, with the exception of support material. So I think and they go by, so they go by cubic inches, so I am staying in imperial units. So I think, and they're not as much as I thought they would be. I think they're about, because most of the support material is usually just the base of the mouse. There's not a lot of support material. It's just the actual material itself. Probably maybe 3.5 to 5 cubic inches. So whatever, if that works out to dollars per cubic inch. It's not, I think I was able to do, now, if you want to, I don't charge my students. If you want to charge a small fee and have your students bring these home with them, my students are going to get them, but my school has socioeconomic needs, so I don't charge my students anything. So if you want to charge your students $5 to recoup some of the material costs. I don't think that's going to be an issue. I think I did an entire class with less than one cartridge. I think if that, or maybe a little more, but it is definitely worth it. I know there is. In this case, there is some material issues, and one of the things that people will have to, the struggles is always is finding funds for materials. So that's and like I said, if you want to charge a small fee to help recoup some of that cost, then that's one way. Absolutely. And my students always take their models home. I usually put them on display. I have display cabinets to allow the students love to have their work out on display, and then after a month or so, I let them bring them home, and they can share that with your parents, family members.
Yeah, Mike hits on it. These students, they go away and they want their parts due to the fact that it's a portfolio piece. It's something to showcase. It's their creation.
Yeah,
it's extremely powerful and impactful.
Yeah, I had, and if I could add one comment, I had a student. We have co-ops, so the student is working half of her day working in a work placement, and she's working with a video game company, and they interviewed 5 or 6 people. And she brought her portfolio, but she also had done some amazing mudbox work, some 3D creature, like some creatures that she had done, and we had 3D printed. And she brought those in her interview, and they loved that. And I think that definitely allowed them to see what she was capable of doing, and just it's pretty powerful. Here you are going in, and you're bringing 3D printed parts in your interview. I think they were very impressed. I don't think. Well, I know they haven't seen that before, and fortunate to her, and she's a great student. She was selected, so she spends her afternoons working with a local company in town, which is the experience.
Right. During your presentation, Mike, you talked about how I think you said it took 3 to 4 weeks that you spent working with your class on this. Can you talk a little bit more about the amount of time that the students need to devote to this, and maybe even break it down by the various design phases that they go through? Can you just talk about sort of how much time they actually spend on these things?
Yeah, so if you provide about a month start to finish, the AutoCAD 2D, so beginning AutoCAD and then the 2D to 3D probably takes the most amount of time. You can speed up the process by having certain aspects of it done at home if you wish. If you want to assign the kids to do their concept sketches at home or their scaled sketches at home, the fact that I use AutoCAD, a lot of software is available for free, so you can encourage your kids to download it and they can work at home. So there are several, although I took about 4 weeks, and the concept scaled sketches, probably you can do that in a week. Between introducing the project and starting AutoCAD, that's probably about a week and a half. I go through a few things before we actually start the project because it was the beginning of the semester. So I think 4 weeks, and so sketching might be 1 week. You might have 1 week for 2D AutoCAD, 1 week for 3D AutoCAD, and then kind of a week to do the kind of a peer evaluation, 3D printing, and then allow some of the other kids at to have a little more time to also finish up. So for me, it's super crucial to have everyone move through the project at the same time. So when we went through the process of doing the 3D part, we did that as a class. So, okay, right now, so you have to recognize these are kids who have been in high school for 3 weeks. So they have their 2D done. We need to make sure that 2D, everyone is ready to do their 3D. So today we're going to start this, and maybe that took maybe 2 periods, 1.5 periods, and by the end of that 2 periods, everyone had their 3D done. So it is, for me, important, especially at the early ages, that as much as possible, the group move through the project at the same time. And that's the tough part, is to having everyone keep up. And that's where they can do extra work. Maybe they need to spend a little bit of time working at home, doing some of their sketching. Maybe they come in after school. Maybe they, if I need to spend a little more time with a student doing AutoCAD, absolutely. He's having a hard time understanding some of the concepts. So whatever works in your environment, that's kind of how it works for me.
Jesse, I just wanted to come back to you. Someone in the audience during your presentation picked up on something you said about maybe the library taking the lead on 3D printing, and wanted to know why the library might make sense as the group to take the lead on something like this.
Well, what we're starting to see across the country, public libraries are looking to add relevancy. Right now it's kind of a place you go look for books when you can't find something on the internet, or rent CDs for a week. They're trying to get more action. And at the school level, these libraries, it's the common space. It's where every student has access to. And it's all about that accessibility and engaging. It's truly a revolution. The technology classes did it. Now we're starting to see the libraries and media centers become more than just a place to take books out from.
Okay. All right, great. Well, thank you. Another question from the audience related to someone in the audience has two Title I schools in their district that have a technology base that does some in grades 6 to 8, or certainly in grade 6, do some studying of the design process. Are there any grant opportunities available in this area that you know of?
Mike, I think I can take this. I know technology equipment, you can use Perkins funding. There are manufacturing grants, advanced manufacturing grants. There's a lot of stuff out there. Don't be afraid to dig around and look. Because we know that there's grants out there, Stratasys offers extended payments. Basically, we call it a lease, but it's a lease to own. And when you do get your funding after, you'll have to have an initial funding, but we'll spread payments out over 5 years, and at the end, you can purchase for $1. Or there are, we know people get grants, and there are 3-year packages, so you can fill with what you have for the grant. But back to it, yes, there are plenty of grants out there. There are no Stratasys grants currently, but check for technology grants, additive manufacturing grants, STEM grants, Perkins funding, that area. And then I'd also even engage with local industry. Local industry is doing a lot more collaboration with schools because they need those skilled employees in the very near future. So we're seeing a lot of industry partner with schools. And we're seeing schools saying, hey, we'll do this, and guess what? While we're not, you can take second priority where we're not printing student projects, we'll print files for you. We'll print models for you. It's actually a great way to engage students with industry as finding out what their potential jobs could be. And industry loves it because that's new ideas. These are ideas, like you saw in Mike's presentation, ideas that people that have been in the industry don't think about on a daily basis because they're so outside of their comfort zone, the box, whatever you want to call it. But that engagement and new ideas, it's a real benefit to the community. So I hope that helps and answers that question.
Okay, terrific. Well, thank you. Well, we'll take one last question, and Mike, I'll start with you, and then Jesse, maybe you can throw in your 2 cents as well. Is as as educators and teachers look to bring something like this module into the education setting, how do you recommend fitting it into the current curriculum? I mean, how do you even go about doing that?
Well, for me, it was quite easy. This fits in exactly, coming from Ontario and Canada. It fit in with a lot of what I was already doing. What I would suggest, as I said at the beginning of my presentation, I would just take the module and whatever adjustments or alterations you have to make to fit your environment. So what specifics, there may be just a part of it that works for you, and maybe in my case I was able to use the entire process. So there may be things that you have to add to it to satisfy your curriculum, or maybe there's things that you're just going to pull out of it. So in that case, I would it's just a resource that allows you to utilize, one, it gives you an opportunity for a project you might not have thought of with some of your classes, and secondly, it gives you an opportunity, I've never thought of doing that with my machine. So it's a great project. So the computer mouse was a great project to do with young grade 9 students, and it was a great project to use my uPrint machine with them. And they loved the experience. And that, for me, that's what it's about, right?
And from the Stratasys standpoint, we're working on these modules to fit into a current curriculum. We're not looking to take over a curriculum because we're not writing things around Common Core and the necessary standards yet. So these are pieces that fit into a design in engineering, a pre-engineering, character design area. And that's what we love about a module. And the differing between a 3-day module and a 3-week module is based on what a school can fit into their day-to-day.
Terrific. All right. Well, thank you so much. Well, that is all the time that we have left today. We've gone over a little bit to make up for that silence at the beginning, for which I apologize again. We didn't get through all of the questions, though. So if you asked a question that we didn't get to, someone from the Stratasys team will follow up to get you some answers in the days ahead. And as we wrap up, I want to thank Jesse Reutenberg and Mike Santolupo again for really 2 excellent presentations. I'd like to thank Stratasys for its support as well. So one final reminder before we all head out for Thanksgiving, we will send out an email to everyone who attended today when the recording of the webinar is ready. So thank you again, and this concludes today's webcast. Goodbye.